All right. So in this case, I need us to have a continuation, still on our strain energy, working with the shock loads. But this time they are going to be shock loads to the compound bars. All right. So talking of the steep bars, we had these guys previously. We just worked the shock loads where it is just a single bar that we are having. But this time it is now consider the compound or the stepped or the stepped bars in actual sense, where you will notice that there is changes that can happen in the diameter when we are given the bar that we have. It can experience changes in diameter. From the previous one, when it is just a single one, it was fixed, a diameter that we had. So we are going to have a simpler presentation. Like previously, guys, we saw this part of our shock loads that we're going to have something like this fixed on top. Okay, so this will be fixed on top. Okay, so just gonna have this fixed, and we have got as we have to consider, let us say we have got bars that are in series. So I'm gonna work first part with bars in series. Let's say we've got that. Okay, then we're gonna consider the first part. Let's just say this is one. Remember, this will be hanging down like that, facing down, and this will be the second one to the what? To the collar. Okay, so this is just gonna be the part of what? Part of our collar. So as we are to consider on this presentation, we will see that this is the first bar that we had, the second one. So the first one, definitely it will have its own length. The second one, it will be having its own length. So let's say this is the length of the second bar, and this will be the length from here to here of the what? Of the first bar. Definitely, again, the diameters, as you can see, they will be having a certain diameter and a certain diameter as well. So we said a mass is going to be attached. So let's say there is a mass that is going to fall a certain height, which is our load. The mass or the load, which is going to fall for a certain height to the collar. All right. So it has fallen a certain height to the collar. And we noticed previously that there will be what? Extension that can happen. So in this case, we are talking of extension that can happen. There will be extension of the first one, and there will be extension of the second one. So let's say there we have got extension of the first one. Then we also have the extension of the second, because there are two. So this one in the series, it will have its own extension. The second one, it will have its own extension. So what is the effect of these? What is the effect? The effect, guys, is on the height that is fallen by the... Nothing has changed. Therefore, the total distance fallen by the load, which is fallen by the load, which is our mass, will be equal to what? H plus x1, the first extension, plus the second extension. Meaning to say this part here is part of the extension, our x total, x1 plus x2. Remember, in series, the total extension, x1, x2. So meaning to say this was going to give us, at the end, we are talking about h plus xt, which is total extension. This will be the total distance that has been fallen now. So if that is the case, guys, nothing has changed. The adjustments will be the adjustments. They are the ones that you just make to say you are in series. What is it that you consider in what? In series. As we had in series, let me conclude what we had before. Remember the force there, because there will be an equilibrium, same force. So meaning to say F1 is equal to F2, which is the force, the total force of the given object, which is our bar. Then xt, which is the total extension, is equal to x1 plus x2. Extension 1 plus extension 2. But remember, how do you calculate each extension? The extension is given from where? We talked about this, guys. That is FL over AE. Remember, that's your extension. So from there, it means your x total is going to be x1, x2. Meaning that this will be 1, 1, 1, 1. But in a series consideration, you will notice that F is going to be the same and also E will be the same. Okay, so this is it, guys. Let's say we are given a consideration where F is the same and also Young's modulus is the same. You are going to notice that your xt now, which is your x total, the total extension from x1 plus x2, it was going to be x1, which is the first one, that will be FL over AE plus the second one, x2, which was going to be FL. Guys, I talked about these manipulations. If you still remember, we just need 1 or 2 there. But since F is the same, E is the same. So I'm just going to put 1 here and put 1 here, put 2 here and put 2 here for the second one, because these two are the same. So meaning to say our total extension, we can even factor out F over E because F is the same, E is the same. So you remain with what? L1 over A1 plus, here you're going to remain with L2 over A2 if they are the same. This will be the presentation for X total. So with this, let's go back now to say, what was it that we had before? Remember I said previously in our previous class when we're dealing with these shock loads, I said this whole issue of the shock loads is on the energy, the potential energy. It's all from the energy. That is where the formulas are. So we can conclude now from the energy. Remember, there is a loss in potential energy which just happened there. So we are going to relate that, the loss in potential energy to what? To the gain in what? In the strain energy. That is what we have. Knowing that potential energy, that's mgh, the height. But the height now is affected because of what? This. The total distance fallen is now what? H plus x total. This is what you'll notice this time. What about our gain in what? In the strain energy. Has it changed? No, it has not changed. Remember in our previous class, we used half of fx, which is equal to f squared. We ended up with f squared L over 2e. Okay, over 2ae, or you can represent that with 2ea. Remember, this is what we ended up with in our previous class. So this is not going to change. But look now what is happening. Remember, you're talking of the total. The loss of it. The gain is also supposed to be the total. So meaning to say, it was supposed to be the strain energy from the first one plus the strain energy of the second one. It was supposed to be like this, U1 plus U2. This is what we are supposed to have. Just like here, which is U total. Okay, so I'm just going to write this as U total. But the U total now, we are going to make adjustments there on our formula. Because also here we need adjustments to be made. So let me just write this as U total so that you understand me, guys, okay? So how are we going to have U total? Just like what we had here on X total, there were 2. In order for you to obtain the total strain energy, it is supposed to be from strain energy, which is caused by the first bar, plus that one caused by the second bar. So how are we going to relate? Remember our strain energy, how you're presenting it. F squared or F squared L over 2A. So this is what we're supposed to have. Just like what we had, you substitute. So you're going to substitute, guys, F squared L over 2AE. You do the same thing here because there are two. F squared over 2AE. This is what you're going to do. You have your U total. But we're noticing that this is not going to change like what we had. Remember, F is the same. So you're going to consider that F squared and F squared is the same. The 2 that we are seeing here and the E, the 2 and the E, because E is the same. So definitely you're going to factor out it as 2E. So what is not affected is the length. So the length of the first one and the area of the first one are not affected. The length of the second one and the area of the second one are not affected. But these ones are the same. The force, the Young's modulus. So if they're the same, there's no need for me to write 1 to 1 because it's just one and the same thing. So I can even factor it out because it's the same, F squared. So I'm going to factor this as F squared, also 2E, because 2E is the same. So I factor that out. Mathematically, what are we going to have? L1 over what? Over A1. This is what's going to remain, plus what's going to remain here? L2 over area 2. So that will be L2 over A2 like that. Meaning to say for the total strain energy that we're talking about here, this is going to be the adjustment now made on our formula. We are going to have this adjustment. What about XT? The adjustment was supposed to be in terms of force. We need the force. So we're going to put this. So therefore, this formula in a combination or in this series combination, we can conclude that therefore the loss in our potential, which is mg into h plus x total, we substitute our x total here as it is. So as you can see, there's a bracket there. So we're going to need at least 2 brackets here. So let me put it this way. So it's going to be mg into h. So this is h plus the x total. We substitute. Remember, this is the formula for x total as it is. So that's f over e into, that is going to be L1 over A1 plus L2 over A2 like this. So this is what you're going to have. And right, so let's close this bracket. So we substituted this whole part here. All right, let me put it this way. This whole part that I'm indicating here, this whole part represents our X total. This is your XT. This whole part is our XT as it is like this. That's our XT, the total extension. This is our XT, the total extension. We just substituted. We do the same thing on this total, which is the gain in our strain energy. What is the answer there? This is what we got. If there are 2, so it's going to be F squared over what? Over 2E, which is into L1 over A1 plus L2 over A2. So at the end, the formula can be given in this way. Considering that we are dealing with an equation for an impact load. For an impact load on a stepped bar. So that will be the condition. We're talking of a series there. Series combination, consider that part of the x1 plus x2 being equal to x total, because you are in what? You are in series. Talking of a series. So this is how our questions are going to be like. So as you can see, according to your formula sheet, you are limited. So you are the one who is making all these adjustments. So I want you to have your formula sheet. Remember, we had this formula dealing with our shock loads when we use this formula. So now it is you who is supposed to make adjustments. The X has changed. It's total that you're talking about. In terms of this part, they are now depending with the number of bars that are there. So it will be the sum. You have to consider the sum of that, sum of strain energy. You manipulate your formulas from the sum of strain energy, where you're going to have that F squared L1 over 2 A1E plus, you consider add another one, and so on and so on. If there is another one, you have to add another one and so on. Just talking of 2 bars. So you see, the formula is limited to this. So you make adjustments from there. I think I talked about this on our previous class. So we just have to relate to that one. Okay, that was our previous class. You still remember this one? We had only this. It was just X because it was just a single bar. This one, it was just a single bar. Now it's no longer a single bar. We have to make adjustments from, because they are now in series. What is it that you consider? Go about your series bars. I talked about that of the series, the compound bars in series, like as a part on its own from the stress and strain, if you still remember. So let's consider our questions. See how these questions might be given. A stepped bar is shown in Fig 2.13. So there is a stepped bar that we are given. The material of the bar should not experience a tensile stress greater than the material of the wall of the bar that is given. Is not supposed to exceed, meaning to say we are given the maximum stress. And I talked about this issue of the maximum stress, 80 megapascal. Maximum stress. From the section with smaller area, smaller cross-section, that is where the maximum stress is found. So this area, this section with a smaller area, with a smaller section that we are seeing, is the one that experiences the maximum. That is where we have our maximum stress. From the smaller section, we can find this. Meaning to say, that's where we're going to have what? The smaller area. Smaller section in terms of the diameter, that means smaller area, remember. Where the smaller area is, maximum. Why is that, guys? Let's go back to our mathematics, because you might be wondering, why am I also always talking about this? Because it is force over area, remember. It's force over area. So for this to be maximum, remember your division. This is supposed to be what? Minimum. That's the idea of your mathematics. So where is the minimum area? Where there is the minimum section? Minimum diameter. This is 30. This is 20. You can even look on the diagram, like, because the diagram is already there. So that's the whole idea there. That's the whole idea. So you have to know this. So it follows this will correspond to where we have what? The minimum area. No problem. Determine the maximum height through which a mass of 100 kgs can be allowed to fall. The height, remember, it must fall a certain height to cause what? An extension. So we do not know the height that it must fall, that it is allowed to fall. We do not know that, given that E is equal to 200 gigapascal. This is what we have. Only this. Only this. And what is it that we need? The height. So the question is there a formula that has a height? Yes. From this formula that we are just talking about, we can see that the height is there. From this formula, the height is there. If we take this formula, if we are considering our series bar, this is the formula that you are supposed, and we can see that the height is there. Remember in our last class, we used this formula to calculate what? To calculate the force. So manipulations can be used to calculate the height. Yeah, when we had a formula like this one, when it was a single bar, remember we used this to calculate the force when you ended up with the quadratic formula. If they gave us the force on this type of a question, they were going to ask you maybe to calculate the height. Previous, when we would dealt with the previous question that they gave us, now we do not have. And do not forget it's a combination, compound, series. So let's take our formula and try manipulate until we get the height. So we saw that from the loss in potential energy being equal to the gain, we ended up with the formula. I'm just going to write our formula, guys. We saw how to take this formula. Not going to waste much time. So this was H plus, we're going to substitute, remember, our extension. We ended up with F over E into LA, into L1, area 1, plus that's L2 over A2 like this. So this is what we had, and it was equal to the what? The gain in our strain energy, which we said factoring out that F squared, which is common. So you see, guys, these networks. So let's just try and see if it is gonna work out. Let's see. So if you consider here, it is actually like affected everything. So let's just have our formula again. Like I was saying, guys, you see, working with this software, sometimes just like that, but just hope everything is gonna be clear here. So remember, this was H, and we had our bracket plus the part of the extension. It was F over E, which is into L1 over A1 plus L2 over A2. All right, then we managed to equate this to the total strain energy, which I said because of the series combination that we have, so it's going to be F squared over 2E into, we saw that our formula, it was L1 over A1 plus L2 over A2. This is what we had. So if you're to consider, this is just the total extension that we had. Then we are going to consider now to say, according to our question, we are being asked, remember, it was to determine the maximum height, which I said is the H that we are seeing there. And in order for us to obtain the H, this one, we have to consider what we are given. Are we having this? The mass we are given 100 kgs, so the mass is there. Gravitational acceleration. The force, we do not have the force, okay, which is the same force that we need here. Okay, I'm going to talk about that. The E we are given. The areas, they can be obtained because we have got their corresponding diameters. So you can calculate the areas separately, which is fine, or you can just substitute. But the areas can be calculated. This is 1. This is our 2. So we can calculate the areas. Their areas. Remember, this is our L1 here. It's there. For the second one, we have got our L2 is there. So we need the areas that can be calculated. What about the force? All right. So let's start with the force. As I was explaining, from the maximum, which is the maximum stress, the material of a bar should not experience a tensile stress greater than this. A tensile stress greater than 80 megapascal, which is from what? From the minimum area, as I was explaining, that this to be maximum, it means the area there. Remember, it's force over area. The area has to be minimum. So you need the part which is the minimum diameter, which is this part of the 20. So you're going to use the part with the minimum diameter there. You can calculate your areas and substitute if you're not sure about to say which one is the min, but you can see in terms of the diameter, which one? This one, the one that we need, where the diameter is small. Anyways, we can calculate our areas. Let's just calculate for the sake of us all understanding. So calculating the areas, we are going to notice the first area. As I have stated, this is my first area. We're going to consider our diameter in that case. What is our diameter? That is 30 millimeters. So meaning to say that's 0, if you divide by 1,000, 0,03 meters. So that's pi d squared over 4, which is pi times the diameter, 0.03 squared over 4. So that was going to be our area 1 from this diameter, which was going to be something like 0.007 06. So normally try to avoid like calculating these areas because we can just substitute like as it is. If it is area 1 of it, like here on our formulas, we can just substitute as it is like this. Okay, but if you want to calculate this, you can do that. This is our area in square meters, and we're just gonna write maybe 1, 2, 3, 4 here, which is gonna be 7 comma. So let's just see if it's gonna be 7,06. So it's gonna change into a 9. All right, square meters. We do the same thing for A2, which is the minimum one with a smaller diameter. We can see with the diameter 20 millimeters. So that's where we have what? The minimum area from area 2. That's pi d squared over 4 using the second diameter. So that will be pi times the second diameter. That is 20 millimeters here. Second diameter, 20 millimeters divided by 1,000. That will be what? 0.02 squared over 4. So that was going to give us A2. Right, I left the 10 to the exponent of -4 here. Okay, something like this. All right, so A2, if you simplify it, was going to be 0.003 14159, something like that in square meters. So you can also do the same thing. Have this 1, 2, 3, 4 up to this one. So it's going to be 3,142. This one is going to change into a 2 to 3 decimal places like that. Okay, times 10 to the exponent of -4. You can use -6. You can even just use as it is here, just substitute. So from the minimum diameter, as we can see, this is the minimum value in terms of the area. This is our minimum. So with that, we are going to consider now calculating the force, because this force is the only part that is missing here. If the maximum stress is there, we can calculate what? We can now calculate F, which is the force corresponding there. So the force is going to be what? That is, we're going to multiply the stress that we are given times the minimum area. And in this case, according to our diagram, we can notice that our minimum area in that case is being taken from what? From A2. So that's A2. So if you're wondering, do you have the textbook is just using writing a formula there times A2, then you're wondering, where is it A2? Why A2? We need the minimum what? The minimum area there. So let's find our force. By finding this force is going to help us to calculate whatever that is missing. Maximum stress as it is given, 80 megapascal. So that is 80 times 10 to the exponent of 6. That is the megapascal times the minimum area, which is our A2. That's 3,142 times 10 to the exponent of -4. So with this, your force can be calculated. And that force was going to be something like 25,136 Newton. So the purpose of the force and these areas, remember, that is the part that is missing here so that H can be calculated. So you're going to substitute just like the previous case that we had or previous class, we have to substitute everything now to calculate or to find what? To find the maximum height that you're given there. So therefore now you're supposed to substitute everything. The mass, according to our diagram, the mass is given 100. So that's 100 times the gravitational acceleration 9,81 into what? H. We do not know that H. This one. So into H plus, that's F over E. So you see now the force that we calculated, now the use now of it. 25,136, you substitute your force. So that's 25,136 over E. Remember our E is given as 200 gigapascal times 10 to the exponent of 9. into what? So this is going to be into L1, according to our diagram, the length is there. L1 is 1 meter over A1. So you can use the pi d squared there, or you can just substitute the areas because you calculated these areas. Remember, area 1, you already have this, and your area 2. So you can use those ones, or you can substitute this pi d squared over 4. It's up to you. Okay, so you already have that area 1. Remember, you got 7,069 times 10 to the exponent of -4 plus L2, according to our diagram. I'm going to take this as 1,2 over what? Area 2. Remember, as we calculated our area, it was 3,142 times 10 to the exponent of -4. So this is what we are going to actually have on the left-hand side. We substituted everything on the left-hand side. This is supposed to be equal to what? What we have there on the right-hand side. And what is it that we have on the right-hand side? On the right-hand side, we've got F squared, which is the force that we calculated. So that is 25,136 squared over what? Over 2E. So you substitute the force, F squared over 2E, 2 times E. Remember, our E, guys, 200 gigapascal, 200 times 10 to the exponent of 9. So this is what we have. Into what? L1 over, so this part is just a repetition of this here. You had this, so it's just a repetition there, 1 over the area that you had, 7,069 times 10 to the exponent of -4 plus 1,2 over what? That's 3,142 times 10 to the exponent of -4. So this is what you have as you equate now. What you had on the left-hand side in terms of the loss in PE is equal to the gain. And you need to calculate H. Remember, this is what you need, H. So how can you calculate H? The simplification thereafter is in your hands. You can multiply this 100 times 9,81 on your calculator. You're going to obtain 981 if you multiply these two. So you can choose to expand the brackets by that 981. 981, it multiplies H here. So it is going to be 981H. Okay? The 981 that we are seeing here, it multiplies this whole part. So it multiplies this, guys. But knowing that there's a bracket there, is it like this? As it is. So it's like 981 times you multiply this as it is, like with the brackets as it is like this. You multiply it to what? To 981. So in that case, you are going to get something like 0, 6, 5, 645, 64529, something like that. You multiply this to the all of this part. Do that. The right-hand side, just simplify as it is. As you can see, there's nothing that is, means we do not have any letter there. These are just numbers. So simplify your right-hand side, okay, and get an answer there. So if you have to simplify your right-hand side, you're going to get this. That was going to be 8,000. That's 8,26711. This is what you're going to have. Simplify everything there. So what will be the value of our H? From this, we've got an equation that we can just use to solve for H. Transpose this to the other hand of the equation so that it can be a negative 981H is equal to, I'm going to subtract there, the 0,64529, whatever that you have there, you subtract that. So that was going to give us 7,6, that's 2182. And you need to find the value of H. And what is affecting our H? 981. So divide by 981, divide by 981, you now have the value of H. And our H was going to be 0,007769439. Remember, this is the height in meters. Yes, this will be in meters. You can convert this to millimeters, which is fine. How to multiply by 1,000? Your answer will be in millimeters. So therefore, our H in millimeters, it was going to be 7,769 in millimeters. That's the height being asked. But you see where we obtained the height from. The formula is the one that you need. The formula, what is the formula connecting these, considering these are shock loads in a series connection like that for these compound bars that we have in a series. Then you combine whatever that you have. What is that you are given? Sometimes they will give you this. They'll ask you to calculate the force, or they'll even ask you to calculate that stress. They'll ask you to calculate the stress for everything. Then considering the total stress, you have to find the stress of the first one plus the stress of the second one. But that stress, for it to be there is a need for a force. And for you to calculate the force now, it was going to be a quadratic because this is F squared, this is F. Just like what we saw when we're dealing or when we're working with a single bar. So this is what you need. Just try to make sure that your formulas are well presented and manipulate. Substitute your values properly with understanding also of some of the things that are happening in terms of the maximum stress, which is not something that is new. We talked about this maximum stress from where the area is small or where we put the smaller section. So it's only that a disadvantage to say our class has been disturbed. I couldn't manage now to take back those notes that have been there. So now, guys, according to our software, we're just going to use this part as it is. But let us just continue to revise, guys, as much as we can. Also, trying on our side to have flexible softwares which can help us also to give you guys what is applicable at the right time. Till we meet again.